Hello everyone, so we are gonna design function to solve n-queen problem, which is placing n chess queens on an n times n chessboard. So example, using the original chessboard for size of n is 8, then there is a 8 position which each of queen cannot attack each other. Okay, so this is the example. Okay, board 8 times 8. So and then this is the data definition. So n is a natural number, start from 0. So it means a number of column and row for the boards, which is the same size of square. Okay, and position is a natural number. Then represent the queen position in the board. So if the 0, so it means the queen is in the upper left corner. Yeah. Right, so and the board is empty, so no queen at all, and then also the list of the position of the board, so queen placement up to the square of n. Right, so all right, this is all the solution. So for the board 4 times 4, so this is all the list of the position. Okay, you can see here. Right, so how we gonna start? Okay, so we need to make a domain analysis. Okay, so first we start with the empty board. All right, so we only have this data. Okay, the natural. So example, using the n4, so board 4 times 4, and start with the empty board, no queen at all, and then we build the possible list for queen for all the position, and then we spread it out to the 16th position. So we have a 16 board, so all its queen placed in this position, and then we start with the first queen with the 0 position. The next he will produce only the 6 because we have the filter function with the queen thread. Okay, so if the same column, so there is no queen here, same row, no queen here, and then same slope, no queen here. Okay, so slope. So then we build again function with this two positions, right? So then again we filter again for with these 2 existing queen, and I'll produce only 1. For this one you can produce only 2, right? So this is the way we will make it the code work. So you can see here, so we make a tree here. Okay, we make a tree structure here. We generate the tree. So we generate the tree, and then yeah, we need to backtrack. So if this solution is not work, so we need to go to another branch to see if there is a solution available. Right, so first make some signature. We produce the code. Sorry, some natural. Produce the code, and false if no solution. Solution. Put here. And then we make some stuff for the function. So and queen, so queens and box. And then we need to make the unit test for this function. start with the 1, produce list 0, it's only 1, and make it faster. 1, 2, 3. One, 2, 4, 6, 7, 8. This one will produce false. That's our solution. Also this one false. Equal to 4 should produce this list position. And then port 5. This one 6. This one 7. Right, so this is the unit test. Okay, so we try to run. Right, all 8 tests is running. Yes, there is some failed, but this unit test is working. Okay. So we need to make a function, 2 functions at least, that call each other to make the 3 structure. So I put this out. The first function is a consumer bound. I think but faster. Board, and then it will call another function for the list of board. BD since it's a list, right, so this is if the empty, then not empty, then something for the first LODD, and let's LODD. So first LOBD is a port, so we call this function port. Then this one is a recursion, so we call function set function port LOBD. Alright, so that's the template for this tree structure, and then we need to generate. So to generate, can use this structure question on the board, and then insert, and then if else, then yes. Next, right, so what is the question? The question if the list, the port of the length is the same with the end, so it's a solve. Okay. So this one minus off. code, same with the n. Then the answer will produce the board. If not, then function or LOBD export this one. So this next board will produce the list of board here. So, but if there is no board available, and then we use false. And this one for the backtrack, can put local here. If I try, then so to activate this backtracking, so if false, try, then try, else we call the rest of the board. Okay, so he find the next branch for the solution, right? So this is the main core of the code. The next we need to make this function. This is the hard one. So okay, next board comes from output and produce a list of board. Produce a list with right, so yeah, if you remember of the domain analysis, so we need to generate this one. Okay, so we need function composition. So first we need to build the list. We use the built-in function for this one. So send build list square of n. Right, so we build all the possible queen position. After that we need to filter queen from attack and compare it in the existing queen in the board. And after filter, and we need to place the queen. Please save queen into the board. Right? So this is the function composition. And then for the filter is a collection of boards. Produce a board. So filter queen filter board from that from existing queen. Maybe it's better this one. Maybe so. Since the filter, we use another built-in function. Some can like this or not. Getting that back. And then we should be done. Right. So since we need to make it simple, so we use this lambda function. Okay, so we make a function here. So it's a p1 for the port 1 we still need the not. Not it's a primitive function. So now we need another built-in function, map, and we need another parameter for the position 2 for the port 2, and then we put here function p1 not get text by p2, right? I think this is the should be like this. This is the structure for the filter. So we need to make this function, the get attack function. So get attack function consume position 1 and position 2 and produce boolean. Produce true if Queen at the same column, row, and same diagonal slot. So get the tag b1, b2, right? So maybe we need some picture. So right, so this is the position, and we need to define as it's a column, okay? Column 1, 2, 1, 2, 3, 4, 0, 1, 2, 3, 4. And then if the same column, then true, and the same slope. It's a 45-degree line, so the slope it should be 1 or -1 if a different line. If the line goes down, so it's a minus, goes up, it's a plus. So okay, we need to make this position. Okay, so how we do it? Okay, I think we need to put local and define its x and y position. Okay, so x1 for position x position 1, we can use it in reminder function. So it's a p1 consume p1 and n, and for the y1 we use a dividing, so it's a quotient. So p1, then we define x2 p2 and define y2 p2, close it. So I think we need to use OR. Okay, so if one of the condition is true, then produce true. So OR, the first is the same column, so x1 same with the x2, and then for the y, for the row, and then for the slopes, the same slope. So the slope is I think this I need to make it start from y, sorry, minus 2x and should produce one. We need another one. But we put the minus here. Right? So this is, I think, okay, try to run. Oh, no, nothing. Alright, we need to activate the function for start. We need another function. Okay, sorry, my mistake. We need another function. So it's consumer port and produce list of port. Let's safety queen. Place its queen into bold the existing existing queen into the bold. And so let's say PD 1, 2. So since we need to add each of safe queen, so I think we can use the map function. Okay, map some function here and PD1. To make it simple, we use a lambda. Method PD1 and PD1 into PD2. Okay, check run. Itu, oh, this function is not defined. My mistake. We need the lambda function. Okay. Okay. Try again. Expect to argue, but only one. Okay. So build this square type LDT. My mistake. Okay, run again. Our map must be function that accepts zero. Okay. Our map. Surround that. Okay. I think I know what's the problem here. Okay, so we need to put the board, not yet to put the board here, so that's why it's error. Okay, try again. Okay, take a long time, see if it works. because we check 8 boards, so okay, it's 8 test pass. Okay, because we check the 8 boards, so it takes quite long. But if we comment it out, see if it's faster. Okay, so it only use the until 4 now. Okay, faster. You add another, even faster. Okay, we put 6 here, still faster. But maybe if we add 7 or 8, it will take a longer because it's a more to check, because it's using. Okay, 7 still faster, and this 8 will be longer because it's yeah, more possibility to explore. Yes, takes a long time for the. Right, all 8 tests is passed, so our function is working. Right, so this is it. So hope you guys understand, and you can try by yourself for this code. Okay, thank you for watching, and see you next time. Bye.